Hi everyone, welcome back. Today I'm going to talk about the formulas that you will need in order to be successful in any geometry exam or test. So the first one, and these formulas, I must state that they do not give these formulas on any reference sheet. So you have to have it embedded in your brain so that on that given day that you're taking the exam, you can extract it from your memory box and start always writing the formulas to show them that you know which formula you're using, and then substitute your values for your variables. So in that essence, I am going to first start with the distance formula. The distance formula, you use it when you need to find the length of a given line segment. It could be given, say, the coordinates for A, endpoint A, and coordinates for endpoint B. So if you're given, you will normally say, given an endpoint coordinates here, X and Y for A, and then the other one for B, you'd also be given your X and Y coordinate. All right, your values there. Now, first thing first, label these. This would be your X1. So this would, whatever value you have here, say for instance, if you have A is 3 and this is -4, and B is 2 and 5. So whatever you have here, A would be your X1, and the Y coordinate here would be your Y1. This you would label as your X2 and Y2. All right, once you label that, then you're able to now substitute into your formulas. And once you substitute it into your formula, you go ahead, you square your what you have here. You have to say, for instance, if you have this one, you're doing your X2, which is 2 minus X1, which is 3. 2 minus 3 is -1. -1 raised to the second power. You do the same thing for your your Y values, right? And then you add the 2 when you're done with raising it to the second power, and then find the square root of that. You can further simplify it, but if you don't simplify it, if they say you don't leave it in simplest radical form, you can go ahead and do so. The next one is the equation of a circle. Again, need to know these formulas, right? They're not given to you in a reference sheet. Now, it's parentheses x minus a raised to, close parentheses, raised to the second power, plus y minus b, close parentheses, raised to the second power, equals y r square. Now the r square is usually your radius, right? R square is your radius. Your a and b here is your x and your y value, and that would be your center. So this, your a and b would be what you'd write as your center, as your answer if you're asked to find the center and the radius. Now your a is your x coordinate, b is your y coordinate. Now one thing I must say, sometimes the problem is given to you in such a way that if you're given, let's say for instance, x squared plus 6x and plus, let's say for instance, this particular problem minus 6x, right? And you have plus, say, 63 here. What you have to do, you have to bring this 63 over here, and well, actually this should be positive, so let's make this -63. So when you bring it over here, it's positive. So you have to first, sometime if this problem is given like this to you, you bring it to the right side and you do completing the square, where obviously you're taking the b value here, divided by 2, raising it to the second power, and when you take that b value, what you have there, you would be having x minus whatever the value is there for your b value divided by 2, because it's b value divided by 2. So you, whatever you get here from that, your b over 2 is what you have there, risen to the second power. All right, now one thing I must say to you, if say for instance you have x x plus 3 raised to the second power, and y minus 2 raised to the second power. Now what you will notice there, because this is a plus right here, this is going to, now the coordinate is going to be a negative value. So your x would be -3 and your b coordinate would be a +2, and that's because of the negative here, which is in the formula. So be careful with that. All right, please watch my videos, my separate videos on each topic. Now, when it comes to secant length theorem, I also have videos on that. It meets inside the circle, so you're taking the A times the B equal to C times the D. If it meets outside of the circle, because when I say secant line there, I'm specifically, I'm going to show you an example what I mean here. So you have the circle, the lines meet inside of the circle, that's what it means. And for the one that meets outside the circle, you are going to use the A, open parentheses, A plus B, close parentheses, equals C, parentheses, C plus D, close parentheses. Okay, now what I must say to you is that with this particular one, again, I have a separate video on that one. Watch the video on that. That will help you tremendously, right? And then for the secant and tangent line, right? So this one meets outside the circle, so you might have, say for instance, a line that goes like this. Sorry, let me go back here. Okay, and then meet outside the circle. All right, so you have A, B, C, and D. So this is where the formula is. That little piece that's outside the circle, you're going to add it to this piece that's inside the circle, but multiply that total by the piece that's inside the circle. Okay, so you have to be careful with that in that one in particular. Now you also have the secant and tangent line. You have to know these also. You know that a secant line touches the circle in one place, and tangent line touches the circle in one place, and then you have the secant line that's going through, and they meet outside here. All right, the tangent line is usually one with the A square, and then you have your B and your C here. All right, so you have to remember those things. The secant angle theorem, right? This one I'm going to talk about with you to discuss the secant angle theorem. All right. Now, the secant angle theorem is a case where it meets inside the circle. All right. So you are taking the x plus the b over 2. You need to know that. You need to, for the one that meets outside the circle, the bigger minus the smaller divided by 2. Same scenario. The ones like this. You are going to take the arc here, all right, the angle here, all right. So you're taking, this is the A and this is your B, and then you're dividing by 2 to get the measure of the angle right here or this side, doesn't matter. Now for the scenario, the case where it meets outside of the circle, right, you have your smaller arc here and your bigger arc here, right. You're taking that and you divide by 2 to find this angle right here. So the segment and the segment or the length is different from the angle, but you have to be careful with that. Please go ahead and watch my videos on this because that would help you tremendously. Now, in terms of the segment partition problem, now, let's bring that up closer. So with the segment partition problem, this is usually given to you in terms of, say, a ratio, a 2:3 ratio, or it could be any other value. So first thing you have to do is add whatever ratio they're telling you that segment is cut into. So add it, you get your number. If it was, say, for instance, is 2:6, you have to add these two, you get 8, and you're going to take the first portion. So you take the first portion there, you use the 2/5 as your ratio. This is the ratio that you put here in your formula. Please, your x1 first, and plus the ratio of your, multiply by your x2 minus your x1 value. Plug it in properly. Please label your x1, your y1, because you're going to be given 2 coordinates, okay? Your x1 and your y1. Now, the midpoint formula is very simple and easy. And if, for instance, you don't remember the midpoint formula, which to me, the midpoint formula is the easiest to remember, you can use the segment partition formula and use a half for your ratio there. So you use the same segment partition formula there, and you use your ratio of a half and your x2 minus x1. That's the first part, and you do the same thing for the other part right there. Okay, now in terms of area of a sector, now the area of the sector is like, I also have a video on this. It's the same thing as a, say, a piece, a slice of a pizza from an entire pie. So it's that little segment there coming from the center, and you need to find the area of this shaded part right there. All you're taking is whatever degree this is, your central angle is, put it over 360 and times it by the area of a circle, because it is literally like a pizza pie. All right, and then you will get the area of that sector. Now the arc length is pretty similar, except that you're multiplying by 2 pi r, which you're taking the literally the distance around this circumference of the pie or the circle, but you need just to find that little piece right here. In other words, you need to find the edge or the slice of the pizza, that little slice there. So that would be your arc length, and you times it by the circumference of a circle. So there's a difference here. Do not mix up these. And these are all the formulas that you need to know that are not going to be given to you on any exam. You need to have them embedded in your brain in order to be successful on the exam. You also need to know the formula for an equation of the circle, and that is what I call the Poinsot formula. So you have y minus y1 equals m x minus x1. Now the only value that you're going to change here or substitute is your y1 and your x1. Those are the coordinates that you need to substitute there, and you need to find your slope. Now you need to also know how to find the slope of a given line. If the line is parallel, you use the same slope. If the line are perpendicular, you need to use the negative reciprocal of it. Negative reciprocal of that. All right, and I'll also have a video on that posted on my YouTube. So thank you for watching. Please share, like, and subscribe. Please also watch my videos on the various topics that I have here. Please study your formulas. If you really want to be successful, please study your formulas. Take them to the exam in your brain. Go ahead, tackle that question and do your best. Thank you. Bye.